Okay, here we go, guys. So last time we were here, we looked at factorizing what are called trinomials. And they're called trinomials because they have exactly how many terms? Three terms. And we were looking at that easiest form of trinomial where you have x squared plus bx plus what? C. There you go. And it's important to know where each piece comes from because that's going to determine how you use them. Okay?
How was your weekend?
So, irrelevant right now. Come on.
But I want to know how you are.
Okay, so first, the skills that you need to factorize is you need to be able to list all the factors of a number. So let's talk about what that means. So for example, if I have the number 12 and I wanted to list all of the factors of 12, we always go in order. Remember, 1 goes into 12 how many times? 12 times. Factors of numbers are always in pairs, right? It's not just 1, it's 1 and what? 12, because they have to factor means they have to multiply together to make that number. 2 goes into 12 how many times? 6. 3 goes into 12 how many times? 4. And I know I don't need to try any other numbers because the next number I would try would be what? 4. And 4 is already on my list, isn't it?
Yeah.
So that's how you know when to stop. When you get to a number that's already on your list. Okay? All right. Does that make sense?
Yes.
We also need to know how to combine integers. Remember, that means add or subtract, but we don't call it that because of the signs, right? Okay. And remember, if the signs are the same, we add and keep the sign. Some of you were not having much fun and much success at doing that. If the signs are different, we subtract, keep the sign of which one? Keep the sign of the larger. There you go. Remember that? So if the signs are the same, add and keep the sign. Okay. Okay. Now, so let's say, let's look at each, instead of just saying we need one particular thing, let's just look at every combination of numbers that you could get from these factors, right? I could add 1 and 12. If they were both positive, that would give me a positive 13. I can't add. That's not good. Okay, try that again. They would give me a positive 13 if you add 1 and 12, right? Or you could subtract them, which gives me an 11. Do you agree that those are the two combinations? Don't worry about which sign's which right now. Just think about it. You could add them or subtract them, couldn't you? I'm just saying, what numbers could you get if you add them? What numbers would you get if you subtracted them? Don't worry about what. All I'm doing is adding and subtracting. So let's look at the next two. If I add 2 and 6, what would I get?
8.
8. But if I subtract them, I would get what? 4. All I'm doing is adding and subtracting. There's no what here. If you can't add and subtract, we need to talk. All right. 3 and 4. If I add 3 and 4, I get a what? 7. But if I subtract 3 and 4, I get a what? A 1. Well, I get a 1, right? Okay. Now, you betcha. Now, each one of these numbers I can get could be either positive or negative depending on these signs I started with. Yeah? Okay. But you see that all I'm looking at are combinations of either adding or what? Subtracting. Then I can determine the signs. But remember that if I have to add those two numbers, that means what about the signs? They have to be the same, right? So if I'm looking to add them, that means the numbers have to be the same. The signs, I'm sorry. If I'm going to subtract them, what does that tell me about the signs? They were different, and I want to keep the sign of which one? The larger number. Okay? And once you know the right combination of signs and numbers, then we just put them in those brackets to get the factorizing, right? Because the only way to get an x squared is to take an x times another y. X. Okay? So keeping that in mind, let's review what we did last time. Right? So we had something like x squared. Come on, guys. All right. I don't know.
Is this so fun? Can I wait, what?
Yes, you may. So here I have a problem involving factorizing. Remember, the first thing we want to do is list the factors of which thing? Of the C. Good. And C in this case is what number? Minus 12. Okay? Now, we ignore the sign right now, but that sign is important, isn't it? Okay? So what are the factors of 12? 1n, 12, 2n, 6, 3n, 4. Right? We're trying to find the two that combine to make what?
Negative 4.
Yeah, which we call our B, right? So they have to combine to make our negative 4.
So I'm behind. So I was busy hanging out with Les.
That sounds like. So the first pair of factors are 1 and 12. If I add 1 and 12, what do I get? 13. Is 13 what I want? No. If I subtract 1 and 12, I get 11. Is 11 what I want?
No.
So I know that pair of factors is not what I want. Go to the next ones. If you add 2 and 6, you get what? 8. Is that what I want? No. If I subtract 2 and 6, I get what? 4. Is that what I want?
No.
Yes, I want to. It's right. Right, exactly. But we'll worry about the sign in a second. So, yes, I get 4. But what kind of 4 do I want? That means that the 6 would have to be negative and the 2 would have to be what? Positive. Make the list. Don't try to do it all in your head. Now, but remember, they still have to multiply together to give me what number? Negative 12. Does positive 2 times negative 6 multiply together to give me negative 12? Yes. So they check. They make the middle number and they combine to make the middle number and they still multiply to make the number I started with. Yes.
What's the rules, sign rules for multiplication again?
If the signs are the same, the answer is A.
Positive.
If the signs are different, the answer is A.
Negative.
There you go. Good. So, now the x squared part's easy because x squared can only be x times another what? X. What are the two numbers with signs that I chose to replace my 12?
Plus 2 minus 6.
And there's our answer.
You
So
said round
is
it?
it brackets open X? Oh, you did plus
Brackets
2.
open X.
I did minus
Now,
6.
if you put them in the opposite order, that makes no difference, right? As long as the signs are correct, the order doesn't make a difference. Now, if you reverse the signs, then you're in trouble. Okay? Now, so that's what we did last time. You are going to get a ton of practice with it because we're going to be using it again today to be able to do. What we're going to do is we're going to put two things that we've done together, so you're going to get plenty of practice with these. So we know that it's an equation because it has an equal symbol. Right? Now, the last ones we looked at, which we called the foundation of all equations, were not quadratic. We called them linear. There you go, linear. And we said they were linear because we didn't have any exponents. Now, guys, come on. Listen. Shh. All right. These are quadratic because the highest exponent, or index if you prefer, is a 2, otherwise known as a square, which is a type of quadrilateral, which is where this name comes from. Right? Quadrilateral means like a square, 4 sides. So anytime you have a highest exponent as a 2 or a square, then you know you're working with what kind of equation? quadratic equation. Okay?
Always.
Always. If the highest exponent is a 2, then it is quadratic. Okay? So what we're going to do is we're going to look today at how to solve quadratic equations using a very specific method. And we were learning how to factorize, so what do you think we're going to use to solve it?
Expand.
Factorizing.
Expand.
Factorizing. Okay.
What's the opposite?
To solve quadratic equations by factorizing. Now, there are other methods. This is the workhorse method, though. This is the one that you would use 99% of the time. Okay? The only time you wouldn't use it is if it won't factorize, then there's another method. Okay? But if you don't know this method, you can't move forward. Luckily, it's very easy. Okay? First, set the equation equal to 0. Thank you for that, whoever that was. All right, set the equation equal to 0.
What?
So in other words, I want it to say junk equals 0. So all of the terms are on one side, in other words, right? Now we can move things across the equal sign by either adding or what? Subtracting. So if it's a positive, I would move it by what? Subtraction. Good. Or using a negative. If it's negative, I would move it by adding. Well, whatever we need to do, we have to get every single term on one side. Well, if you subtract everything away or move everything away from one side, then what that's going to do is it's going to leave you 0 on the other. And you're going to see what these look like. Don't worry about it. But setting it equal to 0 means I want everything all on one side. All my number terms and all my variable terms on one side. Okay? So remember when we did linear equations, guys, when we wanted linear equations, we got our number terms on one side and our variable terms on the other. This is a little different. We want every term to be on one side. So we're going to move. Do you see the parallel there? Then we will factorize completely. Now, you will never see me write the word factorize without saying to do it completely, because you need to remember that there are more than one step in factorizing. There's more than one process of factorizing. Anytime we're factorizing anything, the first thing we look for is the GCF or HCF. You might have learned. It doesn't matter to me which one you call it. The greatest common or highest common factor. That's anything that will divide how? Evenly into what? Every terms, all the terms, right? Now, is there always a GCF?
No.
Is there usually a GCF? No, be careful. No, not usually. Okay? Then we count the number of terms, right? And we've looked at only one of them. That's something with how many terms? 3 terms, which factors as using that. We have the x squared plus bx plus c. We find the factors of c that will combine to make what? B. And then it's just x plus that one first factor, x plus the second one, or minus, depending on the signs you get when you factor them. Okay? Third step. Set each factor equal to 0.
What?
Now, hold on. Just write it down. Y'all always say what before I give me a chance to do. Okay? There is no math involved in this section. Each one of those brackets that you get is a factor. And you're just going to take the bracket and put equals 0 at the end. No math. No add, subtract, multiply, divide, nothing. Just put equals what? 0. Because think about it. Factors are things that are multiplied. And if the two things are multiplied together to make 0, one of them has to be 0. So that means we can assume that the factors equal 0. Because the only way you can get something to multiply together to make a 0 is if it's 0. Okay?
No math.
Solve, come on, the resulting linear equations. Write that one down and then let me talk about it. Solve the resulting linear equations. There are two words there that should be of interest to you. First of all, well, solve, of course, because we're solving an equation in the first place. But linear, in other words, after you factorize something, it's no longer quadratic, it's now going to be linear. Because remember when we factored it, we had like x plus 2? The highest exponent there is a 1. So now it's not quadratic, it's linear. And that's one reason we factorize it. Now also notice that it doesn't say equation, it says equations, right? Plural. Because you're going to have more than one factor. Once you set them equal to 0, it's going to mean you have more than one equation. Yeah. And so you're going to solve them. Yep, we're going to do tons of examples. Okay? Now, when we start the examples in Education Perfect, they're going to have already factorized it for you. And so I need you to recognize how we know that it's already been factorized. What do you think it's got in it so we know? Brackets, because when we factorize, we introduce brackets, right? So you're already going to know that it's factorized, okay? So they're going to start off giving you some that are already partially worked, and then we'll move on into the others, okay? We've done all of these skills, we just haven't put it together yet. But now we're ready to put it together, all right? So here we go. So let's look at some of these together. Oops. I hate it when I do that. Hold on. Quadratic equations are where the highest power of the x is what? 2. X, yeah, so 2. So x squared, right? That's the definition of quadratic. If you have a square, then you know it's quadratic. So here's some examples. Now this example, x squared minus 5x plus 6, we ignore that. I don't care. The highest exponent is the one that tells you what it is, right? It can have x's in it, it can or not. But it's the highest exponent you look for, okay? The highest exponent, by the way, is called the degree. My handwriting is atrocious. But the highest exponent is also known as the degree. So the degree of this equation is what? 2, because the highest exponent it is a 2. All right? And what the degree tells you is how many possible solutions you have. So if we have x squared, how many solutions do I expect to get? 2. Now, that doesn't mean we'll always get 2, because occasionally you'll get exactly the same number and we don't need to write it twice. But we do get 2 answers. It just happen to be the same number. So second degree, right? Highest degree is 2, or second degree equation. Right? Now, what's the difference between this one and this one?
That's factorized.
Yeah, this one's not factorized. The bottom one is already factorized for you. And you can recognize something as factorized because it's brackets, right? When we factorized, we created those brackets. Well, they've already done it for us there. We like that. Yes?
Shaking, they use the trinomial thingy to do this.
Exactly. Mm-hmm. You betcha. Okay? So they usually have 2 different solutions. The only time they don't is when you get the same number, what? Twice. And then we don't write it twice. It really exists twice. And if you were graphing, you'd have to know it exists twice. But we're not there yet. You'll get there. Okay? You'll be there. You'll love it. Algebra is your friend. You're going to be so happy.
Algebra is not our friend.
Algebra is your friend. Trust me. It's my favorite thing in the whole world. All right. Other than you guys, of course. All right, here we go. For example, 2 and 3. So for example, here, 2 and 3 are solutions to the quadratic equation, because if you plugged in 2 into the equation, you would get y equals 0, right? Which is what it says. It says all of this stuff has to equal what?
0.
So if you plug in a 2, and everywhere there's an x, and you work it all out, what do you get?
0.
That's how you can check to see if a solution is a solution. You don't need to. You just need to do the work properly. 3, if you plug in 3, everywhere there's an x, you're going to get what?
0.
0. So if you want to check them, you can plug in the answer you get in place of the x, work it out, and you should get a 0. See, all they did was everywhere there was an x, they put a 2, and then did the math. And you should get a 0. Okay? Don't worry about it. I'm not going to be expecting you to check these. That's just something that they're doing to say, okay? All right. So, if your quadratic equation is factorized, then it's really simple to find the solutions because all I need to do is take each one of those factors and set them equal to what? 0. Okay? So, let's take a look at this one. So, how do I know, first of all, that this one is already factorized for me? The brackets. So, remember, our first step would have been set it equal to what?
0.
That should say set. Set equal to 0. Well, what do you notice?
It's already there.
It's already set equal to 0. So they've done the first step for you. Second step should be what? Factorize it. But we've already got brackets, so what does that mean? They've already done it for you. Third step is to take each factor and set it equal to what? 0. Okay? These are the steps for solving. This is just an abbreviated version of what we just wrote. Okay? Right? So it's set equal to 0. They've already done it for us. It's factorized. They've already done it for us. So now we're just going to take each one of those factors and set them equal to what? 0. Okay? So let's look at it. Each one of the brackets is a factor. So what is the first bracket?
It's already down there.
It's already there, but I want you to tell me though. I wouldn't. All right, so what is it?
-2.
So x minus 2 equals 0. That's all you do is just set it equal to 0. Now, when I set it equal to 0, I don't even need the bracket anymore. The reason the bracket's there is to show me that these two things are multiplied together. But if I separate them, are they multiplied together anymore?
No.
So that's why you don't need the brackets. So what's the second one going to be?
X plus 1 equals.
Which means I no longer have one quadratic equation, but two linear ones. So all I need to do is solve both. That simply means, guys, come on, don't panic yet. That just means get the x by itself. In this first one, is the x by itself?
No.
Nope, it's got a 2 subtracted from it. What's the opposite of subtract 2? I'm going to add 2 to where? Both sides. Over here, the 2's will subtract away. Over here, what's 0 plus 2 going to make? 2. Is the x by itself?
Yes.
Then you're done. Let's go to this one. We have x plus 1. We gotta get the x by itself. It's got a 1 added to it. What's the opposite of add 1? So we'll subtract 1 from both sides. On this side, they subtract away and just leave me my x. On this side, what's 0 minus 1? Is my x by itself? Yes. So I have two solutions. X can either be 2, and x is also -1. And that's their solution. That's how easy it is.
Is that how you graph?
Now, graphing would be totally different, so yeah. Okay?
So what's that?
So that gives us our solutions for the equation. We've just solved the equations.
Hold on. So you added 2 to the minus 2.
Right, because the opposite of subtract 2 is add 2. The opposite of add 1 is subtract 1.
Yeah.
Right? So you just do the opposite to get the numbers alone. Get the x by itself.
Can we do one where we have to factor out?
Absolutely. All we're going to do from this point forward is just do more of these.
I have a question.
Yes.
So
Guys,
is what you're saying the solution is x can either be 2 or -1, or they're...
it's both. It has two solutions. So it's not 2 or -1, it's both. So if I put 2 into there, I would get what? 0. Or if I put 1 in, -1 in there, I would still get a 0.
So when you're writing it down, would you just put 2, comma...
Yes, x equals 2, comma, -1.
Oh, I see. So it can be either.
Right. When you could substitute either one of those in, and it would make it turn into a 0.
It doesn't matter which one you multiply, it's 0 to make 0.
Exactly. Okay? All right, guys. Come on, let's look at some more. Okay? All right. So you see that they just did what we did. X minus 2 equals 0. Hello? I don't understand why there's so much talking going on when I'm talking. X minus 2 equals 0, x plus 1. And they didn't show you the solutions. I did. I want to see you're working now, especially because this is still new to you, right? Some of you. So those are the solutions, and they're usually written as x equals, and then you just put your two solutions separated by a comma. In other words, you're making a list, right? Separated things separated by a comma are just a list.
Whoa.
So here we go. Don't select the correct options. I want you to solve it, okay? So we'll walk through the first parts together. First of all, I need to set it equal to what?
0.
What do you notice?
It's already made.
It's already done. Second, I need to what?
Factorize.
Do we have brackets already?
Yes.
That means that's already been done. Third step is to set each factor equal to what?
0.
Is that done for us?
No.
Go, do it for me. Just that one step. Set them equal to 0.
I hope this is right.
And then I'm going to call on somebody to tell me that it's right. That's exactly. Remember, you don't need your brackets once you've done it. Good job.
Does he like this?
So, Bua, you want to be my helper here? Okay. So, come on, guys. Shh. So, I know it's an equation because of the equal symbol. The highest exponent is a 2. That means I know it's quadratic. Okay? So, let's go to our steps for solve. Guys, come on. Let's go to our steps for solving it. The first step is we need to set it equal to what?
0.
Equal to 0. Sorry about that. But what do you notice already?
It's already done.
It's already set equal to 0. Second step is to what?
Factorize.
Factorize. Is it factorized?
No.
No. And I can tell it's not factorized because if it were, it would already have brackets in it, right? So let's factorize it. So this is what we're factorizing. We don't worry about this side over here, right? We're just factorizing the thing. That's why we get everything on one side. So first we look for a GCF. Is there any number that would divide evenly into all of them?
No.
Is there an X in all of them? So is there a GCF? No. Then we count the terms. How many terms do we have? 3 terms. So that makes it a trinomial, right? So I need to find all the factors of C. What is my C in this case? Minus 5. Be careful of those signs, guys. Which the only factors are 1 and 5, yes? And I'm trying to find the 2 factors of 1 and 5 that'll combine to make what? Minus 4. Well, 5 and 1 will add to make 6. Is that what I want?
No.
Nope. 5 and 1 will subtract to make what? 4. Is that what I want? Yes. But what kind of 4 do I want?
Negative.
Which tells me that one of those needs to be negative. Which one? The 5. Which means that has to be positive, right? But remember, I still have to check it against my original. Positive times a negative still give me the negative that I started with? Yes. So those do check. So here we go. Remember, it's still equal to 0. X squared can only be x times another what? X. What are the 2 numbers that I just chose? Plus 1 and minus 5. Now, could you have written x minus 5 times x plus 1? Sure, the order doesn't make a bit of difference. Okay? There's the factorized form. Okay? Now that I have it factorized, I'm just going to take each one of those factors and set them equal to what?
0.
Any math involved?
No.
Nope.
No.
My first factor is x plus 1, so I just make it equal 0. My second one is x minus 5, so just make it equal to 0. All you do is just plunk equals 0 at the end. Do I need the brackets anymore once I've done that?
No.
No, because they're not multiplied together anymore, right? Guys, so now that they're no longer quadratic, I have 2, what are they called? Linear, which I solved simply by doing the opposite, right? Linear, you just do the opposite, okay? So, who wants to help me out here? Let's get a volunteer. Emily! So, to solve the first one, it's x plus 1 equals 0. So, I'm adding 1. What's the opposite of add 1?
Subtract 1.
From where?
Both sides.
Good job. And that's going to give me x equals what?
Subtract minus 1.
Minus 1. There you go. That's all right. Good job. Okay, Charlotte. Okay. All right, Charlotte. So here we have x minus 5. What is the opposite of subtract 5? Add 5, good. So we're going to do that. We're going to do it to both sides. Over here, they'll simply subtract away. And Charlotte, 0 plus 5 is just going to stay 5. There you are. Excellent. Do I have 2 solutions?
Yes.
Yes. So, and you can just circle it like that if you want to. I'm fine with it. But if not, simply you can write them as a list. And my list would simply be -1, 5. Okay?
Yes.
Again, just pay attention to the way that Education Perfect wants you to write it. If they want you to write it as a list, right? Or what each one equals. I don't know yet.
This.
Okay?
Find it.
I haven't done it. Okay?
This?
Okay.
I know.
Such an overachiever. I love
My
that.
mom found an extra one.
Okay? So there it shows you solution. Again, they reverse the factors. It makes no difference. And they wrote them as a list. Okay? X equals 5, -1. Or -1, 5. The order makes no difference, guys. Okay? All right. And you could check it by substitution. I'm not going to make you do that, but you certainly could if you wanted to. All right. So let's try this one, guys. All right.